and I'm very happy to have this opportunity to talk to you today about uranium, a complicated subject. It's not just one substance, as it turns out, but actually hundreds, and I'll explain that. I'm talking about uranium as a shapeshifter because, in fact, this is how it gives rise to literally hundreds of other, you might call them avatars. They're not products so much as they are changes of identity. Shapeshifting is what makes uranium insidiously dangerous because it's not just one element, it's many. Shapeshifting is the ability to physically transform oneself through an inherently superhuman ability. But there are three different dangerous transformations of uranium that take place. When we talk about uranium mining, the primary problem is the radioactive progeny or decay products of uranium, all of which are very dangerous, in fact, much more dangerous than uranium itself. But they're all actually starting off as uranium atoms. In nuclear reactors, we split uranium atoms and we produce hundreds, literally hundreds of brand new radioactive materials which were never found in nature before 1939, which are called fission products. In fact, it was the existence of these fission products which allowed scientists to recognize that something brand new had happened, that the uranium atom had been split. And when it comes to weapons, the first nuclear reactors were actually built for the purpose of transforming uranium into plutonium. And plutonium has become the principal nuclear explosive in the world's nuclear arsenals. I put down here transuranic actinides because there's actually about 36 different materials, all heavier than uranium, all of which start off as uranium atoms, but they become heavier by absorbing neutrons and they transform into new elements. Here's a model of the uranium atom. These photographs are by my good friend, Robert Del Tredici. Uranium is the key element in all nuclear fission technology. It's important to understand that there would be no nuclear bombs or nuclear weapons of any description, nor would there be any nuclear reactors of any description if it were not for uranium. Uranium is the key material in these technologies. And in 1943, Canada formalized its participation in the World War II atomic bomb program. The Prime Minister of Canada got together with the President of the United States and the Prime Minister of the United Kingdom, Churchill, in Quebec, and they signed an agreement to cooperate in building the world's first atomic bombs. Now, why was Canada particularly involved in this? Well, basically, Canada had the only readily accessible supply of uranium, the key ingredient. And this actually was in the land of the Satu Dene people, a nomadic people who had lived for thousands of years around the shores of Great Bear Lake, way up high in the just subarctic, about 100 miles south of the Arctic Circle. And it was on the east arm of the lake that there was a mine, which we knew about for a reason which I will explain shortly. These are bags that they used to carry on their backs to carry the radioactive ore, the Dene people. And the town of Delaunay is now sometimes referred to as the village of widows because so many people died of radiation-induced illnesses. And it's not as if they didn't know about these illnesses ahead of time. As early as 1931, way before the Second World War, there was a Department of Mines document which talked about lung cancer, bone cancer, and deadly anemia, which can be caused by very small amounts of radioactive substances deposited in the cell tissue or bone structure of the body. This was because of tragic events that occurred in the early 20th century, which I'll shortly be talking about. So it was already well known. Don't let anybody tell you that they didn't know the dangers of these materials, and they did. Now, Canada became, because of these historical accidents, it became the world's first and most important supplier and exporter of uranium in the world. And up until about 4 or 5 years ago, it was the number one and had been the number one since the World War II atomic bomb program. Delaunay is way up at the top of the screen there in a place called Port Radium. The Elliott Lake region is at the top of Lake Huron. You can see the blown up circles there. That's where the Serpent River band was at the foot of the Serpent River, that whole system became very contaminated with radioactive byproducts of uranium mining, which Lorraine will be talking about. And all of this material went down to a town called Port Hope, Ontario, where it was refined for the atomic bomb project and also for the Cold War buildup of nuclear weapons, tens of thousands of nuclear weapons, all of which had a significant amount of Canadian uranium in them, either in the form of uranium or in the form of plutonium. Here's the utilization of Canadian uranium based upon the mill, where the location of the mill is. You can see that a lot of these mills produce materials only for bombs. In fact, all Canadian uranium was sold for nuclear weapons up until 1965. Only then did the Canadian government announce that it would no longer sell uranium for weapons purposes, but for peaceful purposes, meaning nuclear reactors. Now, the first example of shape-shifting comes about through a process called radioactivity. It's a form of nuclear energy that cannot be shut off. Nuclear energy refers to energy that comes directly from the nucleus of an atom. And it turns out that the nucleus of the atom is held together by the strongest force in the universe, called the strong nuclear force. This process of radioactivity was discovered 125 years ago by a man named Henri Becquerel in Paris. And the unit of radioactivity is therefore called a becquerel, and it refers to 1 disintegration per second. So here's a picture of Henri Becquerel. He was interested in things that glowed in the dark, and uranium was particularly unusual because no matter how long you put it in a dark place for weeks or months, it would still continue to cause glowing in the dark. A kind of an invisible light was being given off by these rocks. Now, radioactive disintegration involves the disintegration or explosion of a nucleus, giving off subatomic shrapnel, you might say. And the 3 types that are most common are the alpha particle, the beta particle, and the gamma ray. These are all very dangerous to living cells of all kinds. And the number of disintegrations per second is measured in becquerels. And the half-life of a radioactive material is how long it takes for half of the atoms to disintegrate. That means the other half is still there, and it will take another half-life for half of those to disintegrate. And so it goes on and on and on. After 10 half-lives, you've reduced the amount of radioactive substance by approximately a factor of 1,000. Now, radioactivity is dangerous, and the people who mine uranium aren't really concerned so much about the dangers. That's just a nuisance to them. What they want to get is the uranium, to use it either as a fuel or as an explosive. But the people who are the innocent bystanders, they have to be concerned about the health effects of radioactivity. Chronic exposure increases the incidence of cancer, leukemia, genetic damage, also strokes, heart attacks, and other blood diseases such as anemia that Marie Curie died of and her daughter Irene, and even of low intelligence in young children who have been exposed in the womb. But there is a latency period. The onset of disease may occur years or decades after exposure. It's very similar to cigarette smoking. You don't see people smoke a cigarette and then keel over dead. It takes a while. And the same thing happens with radiation. So the effects are many years later and consequently are subtle. They're not easily detected unless you go looking for them very carefully. You can't see radioactivity, but if you put it in a special device called a cloud chamber, you can actually see the tracks of these particles that are being given off all the time. So it's constantly emitting this invisible, you can't taste it, you can't see it, you can't smell it. There's nothing you can do except experience the ill effects of it. And unless you have special equipment, you won't even know that radioactivity exists because it just looks like normal, inert material, but it's not. Marie Curie discovered something very interesting. She crushed up the ore that Becquerel had used just 2 years later, and she took away the uranium. She extracted the uranium chemically. She was a very good chemist. And she found to her amazement that while uranium is indeed radioactive, the residues are much more radioactive. In fact, 85% of the radioactivity is left in the crushed rock from which the uranium has been extracted. And that's true today at every uranium mine in the world. When they extract uranium, they take away the uranium, but they leave 85% of the radioactivity behind. So Marie Curie knew that there must be other materials there which are even more radioactive than uranium. She discovered two of them, radium and polonium. She named polonium after her homeland of Poland. Each disintegration, it turns out, creates a new element called a decay product. So when a uranium atom disintegrates, it doesn't disappear, it transforms itself. That's why I call it a shapeshifter. It turns out that every atom of radium started off as an atom of uranium. And every atom of radon gas started off as an atom of radium, which in turn started off as an atom of uranium. So all of these things are, in my view, they're magical transformations of the uranium atom. They're not produced by the uranium atom. They're new identities. They're new avatars, you might say, of the uranium atom. Uranium has a long decay chain with about 24 progeny. Its decay products are much more radioactive than uranium itself. Now, radium, which Marie Curie discovered, by the 1920s, it was recognized that this is an extremely dangerous material. In fact, they used the danger of the material, the fact that it kills tissues so easily, to fight cancer, because they could burn the cancerous growth and shrink it down. But unfortunately, these young women, who were mostly young teenagers, almost all of them before the age of 20, thousands of them worked painting luminous dials on watches, and they died of a host of diseases. By the 1920s, it was clear that there was an epidemic of bone cancer among these girls, as well as fatal anemia. And they got anemias, bone cancers, and later on in life, they developed head cancers. And all of these were caused by very tiny amounts of radium, so tiny that the chemical methods of the time would be unable to identify it. It was only through the radioactive emissions that they were able to actually find out how much radium was in their body. It was a few micrograms in each case. Radon is another thing that was discovered by the 1930s. It was well known that thousands of miners have been dying for centuries as a result of radon gas in underground mines. And that's been well documented around the world, and particularly here in Canada. There have been great improvements made in controlling the radon in mines today so that miners are not exposed to such high levels as they used to be, but it still causes lung cancer. And the only reason there has been improvements is because of public action. If the public and the workers don't speak out, nothing gets done. Here's another example. Polonium-210, which Marie Curie discovered, was used to murder Alexander Litvinenko in 2006. This is a Russian ex-KGB agent in London, England. They put a little polonium in his tea, and that did him in. Now, polonium, it turns out, is responsible for up to 90% of the deaths attributed to tobacco smoking. It turns out that radioactive polonium finds its way into the tobacco that is harvested. And then when the smokers light up their cigarettes, they're breathing polonium into their lungs. And polonium, it turns out, weight by weight, is about 250 billion times more toxic than hydrogen cyanide, one of the most toxic chemical poisons that we know of. 250 billion times. That means if you had the same amount of polonium-210 as you did of cyanide, you would kill 250 billion more people with the polonium. By the way, these deadly radionuclides, radium, radon, and polonium, are all alpha emitters, and so are uranium and plutonium. Alpha particles won't go through a sheet of paper, but they do enormous harm inside the body. This star is the tracks of alpha emissions from a tiny speck of plutonium in the lung tissue of an ape. And that happens over 48 hours, those tracks. So when uranium-238 is mined, you only take away the uranium, you leave all the other materials behind, and 85%, as I said before, is left in the uranium tailings. Here's a wall of uranium tailings, 30 feet high at Elliott Lake. There's about 70 million tons of radioactive sand behind that wall, containing all of those byproducts of uranium. In the voluminous uranium tailings, thorium-230, which has a half-life of 76,000 years, that's one of the byproducts, reproduces the radium, radon, and polonium for hundreds of thousands of years. So this becomes a perennial, an eternal problem for the environment. The uranium mill tailings hazards are multiple. There's the gas that's given off, there's the seepage into the groundwater, there's the dust blowing through the air. And so over the centuries, this stuff spreads and remains deadly poisonous for hundreds of thousands of years. The second example of shapeshifting is in a nuclear reactor, where, as I said before, when the uranium atoms are split, you get all the broken pieces of uranium atoms. These are more avatars of uranium. So when you hear about a radioactive accident like Fukushima or Chernobyl, where all this radioactive poison is going into the air, guess what? Those are all the broken pieces of uranium atoms that probably came from Saskatchewan. And the third example of shapeshifting is how plutonium and other transuranics are created. And I will end up there. I just think it's important for people to realize that don't be bamboozled. When people say that uranium is not the most hazardous material, they're right. But it spawns hundreds of other materials which are far more hazardous. Thank you.